Hi guys and girls on YouTube, and welcome to my channel. In this video we're going to be having a look on another emerging very common fault on Vestel TVs. Now this seems to be affecting Vestel TVs that are about 18 months to 2 years old. Let's just plug the TV in first and we'll see what the problem is. Right, TV's in standby. Let's just turn it on. And there you can see the screen's lit up. It looks like it's got like a blue hue to it, but that's not part of the problem. That's nothing to worry about. But you can see the screen's lit up. It's like a bluish colour, but it's completely blank. There's no video information on it. Now at the moment this fault is affecting TVs where the back of the screen, this is the back of the screen, is actually sprayed black. And you've got this small back here. I guess it's to cut down on production costs. So if we move back, you can see we've only got a little bit of plastic at the bottom. Now this set's actually a Logic, but that's not important because it's made by Vestel. I've got another one there. That's a 58-inch Hitachi. Yeah, 58-inch Hitachi. As you can see, that's got the same configuration with a small bit of plastic and the black back of the screen. So if you get one of these in, this is the first place you need to be looking. So let's get the back off and I'll show you what the problem is. Right, so that's the back of the telly off. If we move down here, I'll show you what I mean now. You can see this is like a shiny silver colour. It's actually the back of the screen, this, and it's just sprayed black. So this is the model, or not the model, these are the sets that you need to be looking out for. Now if we take a look at the production date on this, there we go, it was actually manufactured week 37 2020, so it's not very old. Right, so with the set on, the first thing you need to do is make sure you've got 12 volts on each side of this fuse on the integrated TCON board. So that's the 12 volt going in, that there is the 12 volt coming out, so the fuse is alright. Now the next check we need to make is on the LCD bias voltages. Now this is just, this isn't the data sheet for the chip in this set, this is just what I've printed off to give you a general idea. So we've got one there, we've got VG high there, VCOM there, and BG low there. So what you need to do is you need to measure these bias voltages. So we just move over into this TCON. They are actually marked, very small, but they're marked in here. So to speed up this video, we're just going to check one of these voltages. Now you can usually measure them on the inductors, one there, one there, one there, and one there. So if we pick one of these, and I'll put a meter on it, I think we'll choose probably that one there. Right, so the set's running. Let's just put a meter onto here. And as you can see, the LCD bias voltage is virtually non-existent. Now if we move over to another one here, and all these voltages are generated by this chip, by the way. So let's just test this one here. And also there's no voltage on there. Now the mistake a lot of people make is because all these voltages are missing, they actually think this chip's faulty. Well, I can tell you it's not the chip, and I'm just going to show you now how to diagnose the real problem. I mean, of course it could be one of these MLCC capacitors shorted, and it's a good idea to check all these, but in this particular telly it's not caused by a capacitor. So let me just show you, taking this one as an example, that has virtually nothing on it. I think what I'll do is I'll solder a piece of wire onto there, There we go, and then we can get some crocodile clips on, and I'll show you how to check this now. Now, the reason why people automatically think this chip's faulty, because there's no output, but if we look at the data sheet, and this isn't for this particular chip, it's for a completely different one, but it gives you the general idea. All these outputs are current limited. See that one there, the output's 450 milliamp. If we move to the VG low, the output's 20 milliamp. Now these chips have a built-in safety device where if one of these rails tries to draw too much current, the chip actually switches off, and that's where a lot of people make the mistake. They measure the voltage and they think it's because the voltage isn't there, the chip's faulty. But what you need to diagnose this problem is you need a meter with a maximum and minimum storage facility, which will actually measure the voltage that comes out of that chip instantaneously before the overcurrent circuit kicks into protection. So let's just connect the fluke to this wire I've soldered on. Now there's probably about 12 to 15 volts should be on there. So let's just connect the fluke to it and see what happens. Right, now remember before we had no voltage on this inductor, so let's set up this to record the minimum and maximum voltage as an instantaneous switch on. So you press that, press that, and this will now record any voltage that appears on that pin when we power it up. Here we go. Right, did you see? It just took a reading then. So if we turn the set off now, if we unplug the set and then we go back to the meter, so the maximum voltage that appeared on that inductor was 12.10 volts. Now that's really all we're concerned with. It doesn't really matter about the minimum. So at one point in time there was 12 volts on that. After the set's turned on, that voltage disappears, but it disappears in the blink of an eye. So let's just swap this meter now for an analog one. Right, so I've swapped the Fluke digital meter for an analog one. We're going to do exactly the same test now, but we're going to do it on the analog meter that of course doesn't record. So I'll power the set up, move over to the standby button. Now watch this. I'll turn the set on now. And did you see it kicked over? Let's just repeat that again. Right, here we go again for the people who missed it. Set on now. And there you see, it attempted to power up that rail, but the excess current circuit in there has switched all the outputs off because one of them rails is drawing too much current. Now you could obviously remove these inductors to see which of the rails is drawing too much current, but at the end of the day all these rails go to power these chip-on films, and what the problem is, it's one of these chip-on films that's actually faulty. And there's no, well, there is a way of repairing them, but you need tens of thousands of pounds of equipment, and I don't know anybody in the UK who actually changes chip-on film. So the only solution to this problem is to fit a whole brand new screen, which is of course more than the set's actually worth. So that's that. I've already priced up the new screen. It's the retail price is £259.15 plus fitting. Delivery time 4 to 5 weeks. The customer's not going to have it done because I mean, this is only a 40-inch telly, so this looks like it's going to be joining that one and the other one I've looked at this week in the scrap pile. Quite often people, I tell people to take these back to the set where the shop where they bought them from, but a lot of people just can't be bothered and they say, oh, chuck it away and I'll just buy a new one. But you know, in reality this is like only 18 months to 2 years old. So anyway, if you get a set with half a back and the rest metal, and you've got the screen's lit up but you don't have a picture, the chances are it'll be the screen. I mean, obviously you've got to check other bits as well, but in all the sets I've had, it's always been the screen that's faulty. Alright guys and girls, many thanks for watching my video, and I'll catch you in the next one. Yeah, not a very smart TV that.